NIH has massive data sets with details of federally funded research grants going back to at least 1985. Where do we get this data? How do we get it? And what's the best approach for getting it? Today, let's explore one option, NIH ExPORTER, which you can see here, and it contains yearly CSV files of research grants. Now, just to be clear, there are two other approaches as well, and I can cover these in another video if you'd like. We have regular NIH RePORTER, which allows you to query and search in the browsers. You might have used this before. Then there's the NIH RePORTER API, and you can access this from Python, R, and many other languages. But for today, let's just get right into NIH ExPORTER. Okay, you can find NIH ExPORTER pretty easily just through a Google search. So we have a list of each project file. Let's go ahead and download one of those, and also the abstract. Go ahead and download there. We're going to link these two together. They don't come in one file, but that's okay. Now let's look at NIH RePORTER. Here's an example here. Let's do a search on suicide in elderly adults. And you can see here, it's a pretty detailed search here, pretty specific. So it's 374 projects. So if you had something like this, it'd be fine. But you can see here, there's a 15,000 max. So if we did something just like suicide, that would be more than 15,000, then we'd have kind of a problem there. So that's when something like NIH ExPORTER or the API even would be a better suit here. Let's go ahead and move these files to our folder, and then we want to go ahead and unzip them. Let's have a look at these and get a sample of what we're looking at. And this might take a couple seconds to open. And you can see here, almost 85,000 rows. All these are different types of projects, and this is just in 1 year, fiscal year 2023. And so lots of fields here. You can kind of see, we have fields like the project title. We have this PHR, and this isn't the abstract. It actually stands for public health relevance, and it's basically a shortened abstract. If you want full abstracts, you're going to need to merge the data sets by the application ID, and I'm going to show you how to do that. Let's go ahead and unzip these files, and then we'll go ahead and put both of the files right next to each other. Okay, so you can see right here, this is what we're going to join on the application ID. So that's the common unique identifier in both data sets that we're going to link by. So that's a way to do that. And you can see this abstract is much longer than that PHR or public health relevance. So this is what we want. This is going to tell us a lot more about these types of projects. Yeah, we're going to do this in Python, but like I said, lots of different ways you can do this. So I'm just going to create a new Python file here. And we're going to use one module called Pandas, which is for data management. I'll show you how to get that in a second. It does not come included with Python for the most part. Okay, we're going to save this in our folder. We'll just call this combined. Okay. First thing we want to do here is we want to import this pandas. And so to do that, we're going to need to go to the command line here. And if you're using Linux or iOS, the process might be a little bit different, but pretty similar. So we want to go to the command line here. We just want to type in pip install pandas. I already have it installed, so it's not going to install it for me, but I just wanted to show you. Okay, so it says requirement already satisfied. Perfect. Okay, that's what's going on right here. Now this reg file right here, that's corresponding to this right here. That's our project details right there. So all that stuff except the abstract. Okay, our abs file right here, that is the data set with the abstracts and that application ID. So that's what we're going to do. We're going to join these two together, and we're going to have one super file. You notice the Latin 1 encoding here, and this type of encoding can handle some of the weird characters you might get in CSV files that the default settings can't. So we're going to join on that application ID. We're going to do a left join, so that has everything in our reg file, and there are a few abstracts that aren't there, and that's okay, and we'll be fine. We can still use the PHR in some cases when we don't have an abstract. This line of code is removing any non-ASCII characters from the string columns in our merge data frame here. So some data sets might have special characters like accents or symbols. We don't want any of that, and those aren't part of the ASCII standard, so we want to remove these if we can. All right, so what we're going to do here is we're going to get ready to export the merge data set here, and these two lines here are going to prevent Excel from thinking a string that starts with an equal sign might be something like a formula, and we don't want that. And we also want to prevent hyperlinks because those can cause problems as well. Before we finish up, we just want to finalize our export details. So let's just make index false. We don't need a row ID. And let's just go ahead and run this and see what we get. Look on the left side here. You're going to see a new file here. So you're going to have the PRJ and ABS. So it's going to have the abstract and all those project data details. So let's open it up and let's see what we got. So usually at the end, you're going to see something. So I had my abstract field in lower caps, so you know that's it right there. The rest of them are by default in all caps. Okay, so you see that right there. So this is the NIH ExPORTER way of doing things. One complaint of this method is you have 85,000 or so projects, but how do you find the ones that are relevant? Don't worry, I have a method for that. What we can do is create some keywords and phrases and search the titles and abstracts. And in theory, the higher the count, the more relevant the project is. Let's go back to our Python code here. So let's just define a list of keywords. You can do as many as you want. I'm going to do suicide and mental health, for example. So we're going to count each time these appear in the abstract and in the title. Let's create a function for this to search the keywords in the title and abstract. So finding this right here, or make sure this is a string. We want this to search everything in lowercase. So if you have, for example, suicide is a capital S somewhere, it might not count that. We don't want that to happen. So we want everything just to be lowercase. It's easier that way. Let's start the title keyword count. Actually, these spaces are bugging me. 1 second. Let me fix that. There. Okay, anyway, on to counting the number of times our keywords appear in our title. That's what's going on right here. We're creating a field called title underscore keyword underscore count. You can name that whatever you want. And we pretty much just repeat. I'm just going to copy this. I'm going to do the same thing for the abstract. We're going to actually create this field right here. Let's change that to abstract keyword count. Change that to abstract, and that's looking good. Okay. And then this is our combined score. This is really easy. We're just going to create a sum of both of these together, and that's what's going to give us our relevant score. So you can name that whatever you want. I'm just going to call it combined keyword score. Okay, then finally we want to sort by the highest score. One would think that the higher the score, the more relevant. Might not always be the case, but in general, I think it's, a pretty good method to use. All right, so let's go ahead and run this and see what it looks like. Okay, it's going to take a little longer than that. I sped it up. Let's open this up. Same for opening this too. These are pretty big files. All right, so let's scroll over here. So in our first case here, we have 32. So the word suicide appears 26 times in the abstract. The phrase mental health appears 5 times, so that's 31. And then there's one situation where suicide comes up in the title. So 1 plus 31 is 32. So that's how we get our score. It's not an absolute perfect way of doing that. And there's more advanced ways like using lemmatization or stemming with natural language processing type techniques. But this is just a pretty quick and dirty way to do it that works. Finally, I just want to show you this data dictionary that they have for NIH RePORTER and ExPORTER, and it's the reason I didn't go over each field name and what it means and all that, but this is great. It'll tell you everything you need to know here, and I'll put this in the video description. That should wrap things up here. Let me know what you thought about this video and whether you'd like to see something like an NIH RePORTER API tutorial. I'd be happy to do something like that. In the meantime, thank you so much for watching and subscribing, and I'll catch you all later.